Hello everybody, my name is Nayan Paul and I'm equally excited today to walk you through an end-to-end MLOps implementation, right? And we're going to, end it up with a quick demo. And the demo is based on databricks. So we're going to talk about what is exactly MLOps, the whole 9 yards, and talk about one possible way in which we can implement this end-to-end. Again, MLOps is a little different than data science. We're not trying to solve a very specific business problem, but talking about the entire framework and the life cycle of how we can start by looking into the data and eventually building a model and deploying the model. I want to start with an expectation and an example. Let's talk about an example and let's see how, if this problem has to be solved, how can we solve it? So imagine same way we have two data sets, a product data and an order data. And the product data and the order data comes from two different systems. One comes from SFTP and other comes from RDBMS, for example. Now the intention is through a data lake, we bring the data in, convert the data into a standardized format, convert the data into some kind of a wide table that has a business context, and use that for my data science work, use that for my machine learning and implementation of a machine learning model. So typically it follows a process where I connect to the source, I get the data into the raw, I apply rules engine for curating, standardizing, transforming, validating the data, enriching of the data. I look into data quality rules, validations, understand anomalies of the data, and try to sort of fix those issues in the data. I can perform reconciliation and audit checks to ensure the data in the source matches to the data that I have. I can perform some kind of consolidation so that when I start looking and using business cases, I do not go and look into stale data. And eventually I save the data into a single source of truth. In this case, let's call it the silver zone or the curated zone. And as a byproduct, again, sync up the entire process into a metadata repository. So all the rules, all the changes, all the validations, all the lineages that we have captured till steps 1 to 7 gets converted into a single metadata repository so that people can understand how the data in the curation zone, in the silver zone 7.0 came into being. And we follow the same process for orders data in the bottom, the red line. And the point of talking about this is it's a very repeatable process. There is a data element to MLOps and it is very repeatable. We go through the same process. The rules will be different. The kind of validations will be different, but the process remains same. And in step number 9, what we do is we combine the data. We are saying that yes, we need to combine product order data to see a unified view of products and orders. So we do a quick ETL, nothing but a simple join maybe, and register that as a feature set. We are saying that there is a feature set, there is a set of features from product and orders combined together to create one single white table, and that feature set can be used to perform data preparation, data pre-processing, and then eventually model training and then deployment of the model. So this is in a nutshell typically how a data view is. It's very critical to have the data view. It's important to understand that we are working with a recent and trusted version of the data, and that trusted version of the data would be used for machine learning. Now let's look into and deep dive into all of the sections, right? So there are 3 sections we talked about: the data view, where I go and get the data; the ML view, where I go and build the model; and then the ops view, where I productionize the model. So let's talk about the data view first. I'm not going to expand that, exactly what we talked about in the previous screen. So we find, n number of third-party data, internal data, external data. We find all possible data sets that we think are important for solving a business case. We onboard and get the data into a single repository, possibly a data lakehouse. It goes through the same process. First lands into raw. It goes through sanity checks, data curation, data standardization, data quality, confirmation, gets saved into a cleansed zone, runs through multiple ETL hoops, combines multiple sources together to create a data asset, to create a feature set, and then everything is registered as a data product, right? So nothing new in this view. So let's talk about, once you have the data, what happens? How does it now help my ML process, and then how the ML process eventually looks like. Now, one important thing that we talked about was capturing the metadata, capturing the whole lineage, capturing the entire information about the data pipelines. Now, this becomes a byproduct, right? It says, once we have all these pipelines registered, once we capture all the pipelines, we end up creating a data catalog. A data catalog eventually can be extended, expanded to become a data marketplace. So once you have a very robust, repeatable, automated data pipeline, you also get a data marketplace that allows you to do data shopping. Which means, as a data scientist, now that I have been onboarded, I've been given a task to do a time series forecasting solution for orders. I want to predict what kind of orders I'm expecting next month for the products I have in my catalog. So for that use case, a data scientist can now go in, look into the catalog, because there can be hundreds and hundreds of data sets and data assets in the system. For a data scientist, it becomes very easy to go into the catalog, search for the data, get an access to the data, and then eventually it becomes a shop data experience. So step one for the data scientist is through a data lake implementation. By building the right governance, by building the right kind of data pipelines, we have been able to give him an access to the data catalog. He can now go and browse the data, find which data sets are important, and then use the data for data engineering and data science work, right? So once he got access to the data, step 4, we divide the entire model building process, like you have seen in this, into small zones, right? So there is a yellow zone, which is all about understanding, iterative way of finalizing your features, right? I might join 2 data sets, I might join 20 data sets, I might get a list of 200 or 500 attributes. Not all of these attributes are important for me. So I go through a cycle of evaluating, exploring, validating, checking through each of the attributes and see which attributes make sense business-wise. So that is the yellow zone, where we have the capability now to wrangle the data. We have a self-service way of standardizing, cleaning up, fixing the data format, date format. So example can be, the data is coming as, one column has date of birth. And typically date of birth might not have a lot of significance in the model. But if I divide it into 4 different attributes and I say year of birth, month of birth, and probably a weekday, which day he was born, day of the week, and possibly his age, these 4 parameters might give me a better understanding than just evaluating a date of birth, right? So it becomes important for us to convert the data into a feature set. We can expand the feature set, we can derive new features. So it goes through a cyclic process where we have capability to create new columns, create new features, understand what makes sense. Then we go through quality monitor, find out the distribution of the data, how much of data is null, how much of data is constant. So imagine that there is a column called sales origin country, and imagine that the company is only selling in US. Everybody's data will still have value as US, right? So that column that says a constant value of US doesn't hold any significance in the machine learning process. So once you look into the data quality, understand the checks and balances, evaluate what attributes are important, you can decide what attributes to keep and which one to discard. Now to do that, we have profiles and statistics, and we call this as an exploratory data analysis, EDA. So we have charts and matrices and reports, helps a data scientist to understand the nuances of the data, and then he can deduce, he can decipher which columns are important for him. Similarly, we have capabilities to do, statistical measures of the data, understand the data in a more statistical way. So for example, feature importance, correlations, graphs of statistics in terms of, distribution of the data, whether it follows a normal distribution or not. So all of these are toolkits in the hands of a data scientist to go through a repeatable process once he has a data set and says, okay, I got a data set of 200 attributes. I think 100 attributes are important to me. But then I'm also creating 40 additional attributes because of all these derived columns that I want to create. So through a cyclic process, through all these statistical measures, through all these profiles, all these exploratory analysis that he has done, he comes to a conclusion that there are 140 columns, 140 attributes that are highly critical for him. Now, once he has those, once he has in the yellow zone, once he goes through that process, finds those important characteristics, finds those important attributes, he says, let's now go and start building a model, right? So he can now do some segmentation and sampling. He can get some capabilities. Again, typically somebody will go and write a new program, a model. But the idea is, in a lot of our clients' engagement, we are trying to provide templatized code. So why to write a XGBoost model from scratch? Why not take some templates and fast track their journey? So capability wise, at step 10.0, the intention is to start with some baseline model, use the 140 data sets, 140 attributes, find out which attributes are important, find the target value, select an algorithm, for example XGBoost, and go and build a model and then track an experiment, right? So once you run a particular job, we are calling this as an experiment, and we are evaluating the experiment and say, okay, I have a baseline model. The baseline model predicts that in next month for these top 10 products, I'm going to see the most amount of orders, right? So once you do that, the intention is to save those experiments, and once you save the experiments, you save some kind of hyperparameters, because when model is nothing but a statistical function, so you try to understand the attributes of the function, and then you save all these model information, the artifacts of the model, into a model catalog, not a data catalog, right? You save it, you evaluate a model in terms of its performance. So for example, if you're evaluating something like a regression analysis that says I want to predict the price, typically you do a RMSE score. There are a bunch of outcomes that you want to evaluate your model against, right? Score your model against. Similarly, when you're doing a classification like a yes or no, you typically tend to evaluate models based on AUC curve. So irrespective of these modeling techniques, the idea is you have a model, you feed the model with these 140 attributes. For example, in this case, you let it run as a default, capture the outcomes, evaluate what is the baseline score, save everything into a model catalog, ensure that people can now search that catalog, evaluate the catalog, somebody can understand what has gone behind the scene. And again, this also becomes a repeatable process. So once you have created a baseline model, somebody might come back and say, baseline model gives me a pretty good measure, and I think my model can give me a good accuracy of 90%. Somebody will say, okay, it's a good start, but I can still use the same model, and let me tune some parameters. Let me provide some, override some parameters, tune some parameters, and let's see how the model behaves. So again, the outcome of the model is not specific. It changes. It has to change based on the parameters you select, and that's an experimentation phase. The blue box is more like an experimentation phase where, as a data scientist, I might run 50, 100 experiments. Each experiment a little bit different from a previous experiment. I can experiment by changing the parameters and hyperparameters of a model. I can even experiment by saying I want to solve the same problem with another algorithm. So instead of solving it using something like an XGBoost, I can solve it using something like a decision tree, right? So that is a journey where a data scientist, he will go through the same process, using the data set, getting some, baseline parameters, tuning those baseline parameters, running that experiment, evaluating the experiment, and comparing that experiment against another baseline. And once he has done this multiple times, once he understands that something works better for him, maybe he have run 50 experiments and he understood that, maybe 49th experiment is the best experiment, and it provides the right outcome, it is flexible enough, and there are features in a model that ensures that you are not over sort of creating a model which is overfitted, right? So again, you can understand and evaluate those based on the kind of outcomes you are seeing. You're running a model against a unseen new data set. You're running the model against and comparing that against some new data sets. All of that can be done in the yellow phase, where eventually you come back and say that model number 49 is the right one. I've done my experimentation. It is the time for me to now go and productionize. So this is where we transition into the ML engineering piece, where a data scientist may or may not be too much involved. He might come back and say, you know what, I've done my part, I've done all the research, I've done all the analysis, I've come back and said, this is what I need, this is the algorithm I devised, this is what I used behind the scene, these are all the hyperparameters I used behind the scene. Now, as an ML engineer practitioner, somebody else needs to take it up, harden that code, make it production ready by integrating that code with something like a notification system, a failure system, all kinds of jazz, and take it to production. So from an ML engineering perspective, again, the model catalog becomes critical. So somebody might say, you know what, model 49 was the right thing to do. So you have a very nice approval. Typically you should go through an approval process where somebody logs into the model catalog, looks into everything, ensures that all the checklists are maintained, he has the right results, he has done the right kind of experimentation, all the hyperparameters are aligned, and he says, okay, approved. So once you do that approval, you go through a process of again packaging the model, right? So packaging means you convert the model, the algorithm behind the model, all the artifacts, and then you package them, you put them into a CI/CD process, and you try to integrate that with a model registry. So model registry is where you save all the artifacts, you save the model as is. So the model is callable, the model is sort of servable. So in an ML flow world, that is something we use from a databricks perspective. There are other model registries available, but I think ML flow tops it all. So from an ML flow perspective, it's again a process where we can, in a higher environment, we can run the process. We can retrain the model in a new environment and ensure that it actually is exactly the same as the baseline. We go through the process, again, registering the model and saying the model is now ready to be served. Again, it can go through all of these, capabilities where once I train the model, I find the best model, I can compare the model. Comparing the model is also important because, like I said, right, things change over time. Somebody might have deployed a model which is a pretty decent model for forecasting, and after 3 months, some other data scientist group might come back and say, you know what, that model was pretty good, but I don't think it takes seasonality into consideration. I've created a new model and it takes care of a lot of other things. So sometimes we might have to evaluate an existing production model with a new one. This becomes a case of champion challenger, where there is a champion model already in production and there is a challenger that has more capabilities, and you replace a champion with a challenger, right? So all of this is important. That's why you need a model registry capability, where before replacing or deploying a model, you evaluate the model against something known, which is a baseline. You do all of that process and you create a model serving, right? A model serving in the sense, how can somebody call the model? Somebody can call the model using like an API, or somebody might call it as a batch process where I run the model at the end of the business day or at the end of business week, and I save the predictions in some place, and that prediction store can be used eventually for creating outcomes, right? And once you do that process, you can eventually follow the same cycle, the green zone, and promote it to next higher environment, right? So maybe this time you promote it from dev to UAT, and you follow the same process, and you move the model from let's say UAT to production. So this is the model view. We talked about the data view, we talked about the model view, and we talked about the deployment view. So these are all the things that you need to follow, the processes at the minimum, to create a very repeatable and automated ML flow. All right, so let me recap. So from what we have, and again, I'm recapping this now with respect to the asset that we have. So all of these processes that we have seen, these are important, but how do we solve it? So we go through a core data engineering process. We capture data, we standardize, curate, clean data, we create profile report, we integrate the data pipelines into a metadata store. All of that creates a marketplace. When a new project comes up, a data analyst says, yes, I want to register, I want to create a new project. He goes into the registration part and he says, I want to build a solution. So he goes through the data marketplace, finds important data sets and says, these are the data sets I need for my model. He goes through an approval process if needed be, and he gets access to the data he needs. Then he can start the experimentation, right? So he identifies baseline feature, goes through the process of the templatized code, and he starts experimentation. So he prepares the data, like we said, discard some non-usable data sets or non-usable columns, and do some feature engineering, through exploration, train a model, baseline, identify the score, evaluate the model and see whether it's better than the previous. And he goes through this cycle of process. Every time he does an experimentation, we save the experiment into a central feature store and a model repository, which means now, things are a little automated. I do not have to personally go and save my experiment anywhere. So one of the advantages of having an automated process is, as a data scientist, I do not really have to go now and start, registering my experiments. So the automated process, every time I do an experimentation, it gets automatically registered into MLflow. We talked about the model repository, the feature store. And this becomes automated so that now if I run 50 experiments by changing certain parts of the model, all the 50 experiments are registered as independent runs, independent experiments, and it's available for reviews. It's available for comparison. And then when the time comes, the data scientist will come back and say, you know what? I've done all things. I've done my initial analysis. I think my model, like I said, model number 49 is what we need. He goes back. Everything is already in the model repository. Through a very nice click. He can actually package everything and save the package into a CI/CD pipeline so that it is deployed into the next environment, which can be in UAT, right? And he follows the same process and goes into production. So this is net how the three things, the data, the model building, and the model ops comes into picture, right? So this is what we have, So you have to take care of three things when you talk about MLOps specifically. The data part, in terms of acquisition, validation, consolidation, standardization, some kind of curation, reconciliation, transformation, data quality. Model implementation in terms of reading those data sets, performing exploratory analysis, some kind of standardization, visualization, feature importance, feature engineering, creating a baseline of the data of the model, splitting the data, to ensure that when you're training a model, you're training and then you're testing the model with some unknowns. Assessment of different kinds of algorithms, right? So we tested our business problem with an XGBoost. Why not test it with some other algorithm like STM? Algorithm selection, hyperparameter selection, model performance, draw some conclusions in terms of scoring performance, and then KPIs, right? How long it took. Does it require some GPUs? Does it require some CPUs? All of that can be evaluated and documented. Again, into the model registry. And then model productionization is about evaluation of the model, whether it is right fit, validation in terms of, is the model doing what it intends to do, model performance, in terms of SLAs, in terms of outcomes, model registration, whether everything is registered, continuous training. Like I said, it's not a one-time thing. Models will change their behavior over time because, data changes behavior over time. Somebody's buying pattern will never remain constant. So, the continuous training is important. Change management in terms of, I need to deploy a new model. I need to override an existing model. So there is a change management process. Drift detection in terms of data, in terms of, what the model's meaning should be. Rebaseline the data, rebaseline the models. Ensure model availability. If the model is supposed to be 24/7 available, ensure that model availability is justified, and then serving the model either as an API or a batch. All of this combined together becomes the MLOps solution. All right. So we'll talk about the data journey first. I know we have talked about this screen in the previously, this is IDF, Intelligent Data Foundation, one of the assets that we have built. And we'll talk about the data journey in this, and then we'll talk about the ML journey and some kind of model registry through MLOps, so ML flow in Databricks. So going here, you build the pipelines, you bring in the pipelines, nothing new, but this is where you start bringing in the data. So you create a pipeline, you say this is a data pipeline that I want to build, and this is where I'm going to start joining data sets together. So we have a bunch of cards you can read, you can repurpose them and create a nice extensible data pipeline. So what you can do is you can say, oh, I want to read some delta table, I want to read some other tables, I might have another data set that is lying in S3, or I might have another table here, right? So there are 4 tables that are important to me. Then what I can do is I can apply some filter in one of them if needed be. I can do some pivoting of another one that's important to me, because the data is not organized, let's say, by customer. I can apply some kind of dedupe in another one. I'm just taking an example, right? And then I can start joining the data sets together, right? So I can join 1 and 2 together. I can join these 2 together. And then finally I join this together again. And I create a data set that is important for me, that contains all the information that I need for my model training. Now we have capabilities in terms of fixing the data, like for example backfilling missing records, finding n consecutive records, imputation. So in data science world, imputation becomes very critical. So if your data doesn't have has a lot of missing values, you can impute some missing values. I can get some ruling aggregates, pre-processed data for machine learning, right? So this is also important. So this is where you can apply, if you need, all these encoding, scaling, so all the techniques for pre-processing the data. So for example, right, let's say weekdays, Monday to Friday or Monday to Sunday, right? So typically, for a model like XGBoost, it's important that you convert things into a numerical value. Sunday becomes 0, Monday becomes 1, something like that. But again, if you give a numerical value, the numerical values have significance, right? 0 is less than 1 and 1 is less than 2. But there is no way that says Sunday is less than Monday, right? So typically you can apply some of these one-hot encodings, encode the data. Instead of saying it is 0 and 1, you can say it is 0, 0, 0, 0, 1. And the other one can be 0, 1, 0, 0, 0 and all the stuff, right? So all of these can be done just by dragging a pre-processing card. And then finally, what you can do is you can split the data, or you can register the data as a feature set. And now this data is available for others to use as well. And you can also register this data as a Databricks feature store, which means now when you start to look into the data and you deploy this as a pipeline, and the pipeline is refreshed on a daily basis. Every day you have 4 data sets coming in, going through all these process, joining the data sets and refreshing your feature store. So now as a person who wants to build a model, you only tap into the feature store and say, I do not care behind the scene what kind of engineering is happening. I'm just using a registered feature store which gets refreshed on a daily basis. And that can be my baseline for building my data sets or building my machine learning algorithms. So this is one view, and again, it simplifies things so much, right? So all your data, standardization, building a robust data set, cleansing, all these imputations. A lot of this heavy lifting of the engineering work can be done by going through the same process. Now going back to the ML now, so this is where we have built a templatized Databricks solution. So step 1 is I've created a data set. The data set is good enough for me to start my model experimentation. I come in here and say I want to explore. So you come into the exploration notebook, you define where your data source is, and then it has these templates, and the templates will go through your data. Again, it is editable, which means if you want to change your data set or do something, you can go and change it. And it creates all these fancy reports. It says, oh, this is how my data is distributed. Age is a numerical feature. There is no missing values, and this is how the data is distributed, right? So it becomes easier to visually interpret, understand the data. Same for categorical values. You can see, oh, these are the values for my data set. And you can decide, like from the missing value, you can decide, what, this data is pretty good, I really do not have to worry. Now you can also do a what if analysis. What if analysis means, before even going and building something, why not analyze, like what changes I'm going to do based on age, how age is distributed based on the jobs, or how age is distributed based on duration, right? So all of these you can evaluate, and you can pick up one single point and say, okay, let me evaluate this, let me see what is going on here, right? So this becomes a very nice what if analysis capability, all baked into your template, that allows people to go in, deep dive, and understand how the data is how the data is distributed. And from this you can understand a lot of anomalies, and then you can actually take out those data if they are actually impacting your model in a negative way. Similarly, you can explore the data. It talks about what is statistical measures of the data, how the data is skewed, all of this data information. And you can get a detailed report that says, oh, what, this is what I found. There are number 21 variables in there. This is how the variables are distributed. If you see age, for people, this is actually a data set for loan approval, and it seems a lot of loans, there are less number of people requesting for loans after the age of 60, right? So they can be actually anomalies. So from a job perspective, you can see what kind of jobs they're having. All of these becomes a very nice intuitive way of exploring the data visually, all done automatically just by selecting your data set. It gives you a representation of how their data is correlated with each other, what are the missing values in terms of metrics if you want, and then some sample records that says this is what it is, right? So all of that can be done through an exploration. So we did the exploration, we decided what is good, what is bad. Now again, this is an iterative process, which means you can come back and update your algorithm again, right? You can say, oh, what, I explored the data, it seems there is a lot of junk in that column, I'll remove it. So you go through the exploratory analysis multiple times before you finalize and say, this is the data set that looks all good. Then you can create a configuration. So configuration file is a way of defining low code, no code. So there are some configurations that define what algorithms you want to choose, what you want to do, right? So it says XGBoost classifier, and I want to do a binary logistic. So nothing important, but it just it's a way of saying that I do not want to write a new code. I just want to provide that I want to run XGBoost. And then you can define and say, I want to run and train and register the data set, which means register the model, which means again you define your final data path, your config file, what kind of algorithms you want, and this kind of a template will automatically go and run the baseline for you, right? So it will tell you that this is the confusion matrix, this is what we are seeing in the outcome, these are the business rules, how many passed, how many failed. These are the feature importance, right? So it seems like these are the kind of features that are actually having a huge amount of positive and negative impact on the model, right? And then finally, it'll automatically, like I said, register everything into MLflow, right? So at this point of time, I found out my data set. I went through a baseline model. I didn't write any code. I just selected whatever I needed, and it automatically got registered as a part of the MLflow, registration process. So I click on here and say, okay, well, I ran a couple of things. Let's look into the parameters. So these are the parameters that were executed. Binary logistic is an kind of a evaluation matrix for us, and then it goes to all these processes and it tells us like what has happened, what kind of imputation was there. So I was talking about one hot encoding, right, and simple imputer. So it says what kind of imputation was done on the data. So all of this is documented so that anybody can read, track, evaluate, and understand what has gone. And then it creates a bunch of outcomes. It says, this is the training area under curve. So everything is documented. It has a precision recall, again, another way of evaluating the model. It has a confusion matrix that says, how many are yes and no. So, it seems like, it's not well tuned, but, no and no is 98%. That means the data is a little skewed here. So confusion matrix tells you, like, true positive, false negative, So if, a person is granted loan and actually he was granted loan, it is yes and yes. And no is, he was not granted loan, but actually, in the outcome also he was not granted loan. And then you have other capability where, actually he was not granted loan in real life, but my model says yes, he was granted loan. So there's a confusion, right? So those are, again, important matrices to evaluate and understand what goes in. And then, there comes some kind of scores, feature importance that we talked about, weightage. Eventually, you go into the models, there's some kind of models that was registered. So again, you have all the experiments, you select an experiment and say, what, I want to register this, I want to promote this. So you go in there, all of this is automatically done, you can see. And then MLflow provides us capabilities where you can actually start promoting. You can say, what, this is not in anywhere, I want to now put it into staging, production, and eventually archived. So all of that can be done automatically through this templatized solution. And the intention is, again, there is no way that I'm saying that this is the only way of doing MLOps, but this is a way of implementing MLOps. Now that our customers and clients are coming back and saying, what, I really want to go and implement something, my time to market is 3 months. I have these 20 data sets that I want to onboard. I want to build this, baseline model. I want to do some predictions. 3 months, I want to get something out, out in the market. We need these accelerators, right? And this is one such capability where, we look into the 3 facets of MLOps. We do not look into the data science independently. We look into all of that, through the data lens, through the model building lens, through the analysis lens, through the model registration, model promotion, and model evaluation lens, and say that, yes, this is how we can actually go ahead and deliver value to our customers. Thank you again for listening in.